All right, please add this to your 2.3 notes. I just have a few examples today, and then then you guys can have your assignment. So what we need to do is move on to, let's see, where would we be? We're done with the quotient rule. We went over some examples of that yesterday. Did I give you?
Yes.
Yeah. I gave you this example.
Yes.
Okay, and I gave you that example. So we are on this now.
Yes.
If a function can be simplified, do that first. Then find the derivative. All right, so f of x is equal to 5x minus 15 divided by x squared minus 9. So like I said, if you can simplify it, and then go from there. So this one obviously is going to simplify, which is why we're talking about this. So what can I do to the top? What does a 5x and a minus 15, what do they have in common?
5.
They have a 5. So I take a 5 out, and it leaves you with x minus 3. And then on the bottom, we have x squared minus 9, the difference of perfect squares. A difference of perfect squares factors to what? Yeah, x plus the square root of that number, x plus 3, and then x minus the square root of that number, so it would be an x minus 3. So we have x times x minus 3 over x plus 3 times x minus 3. What's common to the top and the bottom?
3.
X minus 3, so we just cancel those out. So the derivative, we still have a quotient. So we have to use the quotient rule, and to use the quotient rule, you take the denominator, which in this case is x minus 3 plus 3, thank you, times the derivative of the top. Well, the top is 5. What is the derivative of 5? 0. And that's always a good thing when that happens, because you're multiplying something by 0, that's going to go away, which is always wonderful. Minus f of x, which is 5, the top, in other words, times the derivative of the bottom. What is the derivative of x plus 3? 1. All over x plus 3 squared. So x plus 3 times 0 is nothing. So on the top, all we have left is a negative 5 over x plus 3 squared.
Where did you get the 1 from?
The derivative of x plus 3. The derivative of x plus 3 is 1. Yeah? So my point is this. Look first. Let's say you didn't notice that it could be factored. Is that okay?
Yeah.
Yeah, so it's just going to be more work. So, do the easy work at the beginning, and then it gives you less work to do later.
From now on, or when
All
they
right.
say?
From now on.
Okay.
Yes. From now on, yeah. And I don't even know that I've even given you one yet where it could be simplified. But now you will start seeing them from time to time. All right. Next example, we have 3 times the quantity 3x minus 2x cubed over 7x. Well, you see this 3 out front and the 7 on the bottom? I pulled that out. When I pull that out, what am I left with on the top? Kind of an easy one. 3x minus 2x cubed. What do I have on the bottom?
X.
You have an x on the bottom. So now, what's going on here? I have an x on the bottom, I have an x next to the 3, and I have an x with the 2x cubed. Take an x out of each one of those terms, which is going to leave you with 3 over 7 times. Now if I take an x out of 3x, what are you left with?
3.
3. And then if I take an x out of minus 2x cubed, you have minus 2x squared. And then what happens to the bottom?
1.
It's going to be 1. So I'm not even going to put it there. So really, I probably shouldn't have written this up. I should have just wrote it normal. Okay? That's okay. So now, what do I have? You know. What can I do to this now? 3/7, distribute it into the parentheses, giving you 9/7 minus 6x squared over 7. And then find the derivative. Yes?
How come we factored out the x but didn't write it?
I probably should have made an x. This is what happened. If you're just looking at the 3x minus 2x cubed, and you divide and over x, what I really did was I took an x out of the top, and it left me with 3 minus 2x squared. And then on the bottom, when I factor an x out, I'm left with, when I factor an x out, I kind of pull it out to the side, it leaves me with a 1 on the bottom. The x's cancel out, okay? So I'm left with 3 minus 2x squared. And now we just need to find the derivative of this. What is the derivative of a constant 9/7? 0. And then what about this? What is the derivative of negative 6/7 x squared? It might be easier to look at this like this. Negative 6/7 x to the power of 2. What do I do? Take 2 times negative 6/7, which would get you negative 12/7 x to the power of 1. That's it. That's your derivative.
So what you just looked at them both individually.
Wait, what happened to the 9?
Fractions. When you
For the derivative, yes, because now I don't have like a numerator with a polynomial and a divided by a bottom. Now I just have a regular old polynomial. So I go back to the derivative rules that I taught you at the very beginning of all this.
Wait, what'd you do with
Where
that?
do I get the 3/7? Well, this was the original problem. So I took the 3 in this and I just pulled it to the side just to make it a little bit easier to work with. I didn't have to do that. I just figured if I pulled those out, we would be just working with we'd be looking at our x's then. It would just be a little bit easier to work with.
So what happened to the 9 over 7?
What happened? Oh, this is 0. I was just talking about the derivative of 9/7 is 0.
Oh, okay. Oh, okay.
So actually, this should be 9/7. This should be 9/7. The derivative of 9/7 was 0, so I didn't even write it down. I was just talking about how can we look at this a little bit easier so we can find the derivative of it. So all I did was I took this x squared and I wrote it next to negative 6/7 rather than on the numerator, so it'd be easier to find the derivative. Just the notation I thought was a little bit easier. Okay.
Yep.
All right. I think that this is the last example. These are your favorite kind of problems. All right, the example is f of x is equal to 3 minus 1 over x plus 5. Obviously a division problem, but it's a division problem with fractions in the numerator, so that's not good. So we are going to find a common denominator, clean this up a little bit, and then we're going to go from there. So once we get the top cleaned up, this ends up not being too bad of a problem. What do we do to this? What do we do? We've done these enough, right? I feel like you guys probably should be comfortable with this. What do I do to the top? That cross multiplying thing that we talked about. 3 times x is 3x, we're subtracting, so we have a minus. 1 times 1 is 1. And then the denominator's 1 times x is x. And then we divide that by x plus 5. But I'm dividing by x plus 5, which really you guys know is the same thing as dividing by x plus 5 over 1, which really then in this case means 3x minus 1 over x times 1 over x plus 5. I'm multiplying by the reciprocal rather than dividing. You okay so far? All right, so I'm going to clean this up again. 3x minus 1 over, and I'm going to multiply x times x plus which is x squared plus 5x. Kayla, can you grab the door for me, please? Thank you. 3x minus 1 over x squared plus 5x. Is there anything I can help you with here? Anything I need to clear up?
I don't get that.
Which step?
The last one on the right.
The last one, this one over here. So I was taking a fraction divided by a polynomial. So I made that polynomial, that x plus 5, I made it a fraction, x plus 5 over 1. So when I have a fraction divided by a fraction, that's the same thing as taking this fraction and multiplying it by its reciprocal. So I multiply by 1 over x plus 5. Okay. And now I just take numerator times numerator, denominator times denominator, leaving me with 3x minus 1 over x squared plus 5x. Okay?
Mhm.
Now what do we do? What rule do we have to use? We have to use the quotient rule because we have two polynomials being divided. So do you guys feel like you have the quotient rule memorized yet? Yeah, it's not that bad once you've used it a couple of times. Well, maybe more than a couple of times, but all right, the derivative. The derivative says that you have to take the denominator, x squared plus 5x, and you multiply that by the derivative of the numerator. What's the derivative of the numerator? 3 is what you meant to say. Minus the numerator, which is 3x minus 1, times the derivative of the denominator, which is 2x plus 5. And then I'm going to divide that by x squared plus 5x squared. Which is equal to? I'm running out of room here, but we'll see what we can do. 3, we're going to distribute the 3 in. 3 times x squared is 3x squared. 3 times 5x is 15x. Minus, and this is one of those times when I think using the parentheses is a good idea. We're going to subtract this whole quantity after we FOIL it. So 3x times 2x is 6x squared. 3x times 5 is 15x. Negative 1 times 2x is negative 2x, and then negative 1 times 5 is negative 5. Go ahead, Melissa.
Divided by. Sorry, I was doing that.
All divided by x squared plus 5x squared. Which is equal to. Alright, now I'm going to try to combine a bunch of stuff into one step because I am running out of room. First of all, 15x and a minus 2x, what does that give you? 13x. Okay, and I have to distribute that negative into the parentheses. And when I distribute it in, that means that minus becomes a plus. The 6x squared is going to become a negative. The plus 13x is going to become a negative 13x, and then the minus 5 is going to become a plus 5. So I have the 3x squared here that can be combined with a negative 6x squared, giving me negative 3x squared. And then I have a 15x that can be combined with a minus 13x, giving me plus 2x. And then, of course, I have that plus 5 at the end. All over x squared plus 5x quantity squared.
Yay.
Yay, math!
That's the answer.
That is your derivative. That is
Oh,
your
that's
derivative.
it.
So remember at the beginning of the year when I said to you guys, I'm not going to teach you a lot this year, but you're going to be really good at algebra? This is why. I mean, how can you not be good at algebra by the time this is over with? Aaron, one more.